morning to everyone. Today we are going to discuss about the electrostatic field. So before going to start the electrostatic field, first we know that the what is meant by Coulomb's law. So as per the Coulomb's law, the force of attraction or repulsion directly proportional to square product of the charge point charges and inversely proportional to square of the distance between them. So as per the statement of Coulomb's law, so force is directly proportional to product of the charges Q1, Q2 and inversely proportional to the square of the distance between them. Okay. So we are considering into the 2-point charges. One is Q1 and another one for Q2. The distance between these 2-point charges are distance is R. Distance is R. So this is the Coulomb's law. So now the force is a vector form. Now we are writing into the vector form means, so F is directly proportional to Q1 Q2 divided by R square along the unit vector AR. Along the unit vector AR. Now we can cancel this proportionality. We can introduce the constant F is equal to Q1 Q2 divided by 4 by epsilon into R square along the unit vector AR. So already last class we have discussed into how to find the unit vector. So F is equal to Q1 Q2 divided by 4 by epsilon into R square. Now we are finding into the unit vector of AR means, so R vector divided by modulus of R. So F is equal to Q1 Q2 divided by 4 by epsilon into here R square. This will be R. So we have a R2 into R vector. So this is the force finding into vector form. Let us consider the two vectors Q1 and Q2. The distance between the two charges are R. Now we are finding into the force on Q2 is nothing but a F2. We are finding into the force on Q1 is F1. But how we can write the force means, so F2, we are finding the force on Q2 due to the interaction of Q1. So that's why we are writing into F21. Similarly, we are finding the force on Q1 means force on Q1 due to the Q2. So F1 2. Okay. Now we are writing into the unit vector means, so A 2 1 and A 1 2. So this is the unit vector. So how we are writing into here means, for A2 1 means we are finding the force on 1 from Q2, that is A2 1, and A1 2 means we are finding the force on F2 from Q1. So that's why we are writing into here. This is the Coulomb's law. From this we have defined the term electric field intensity. From this we can define the term electric field intensity. Electric field intensity The electric field intensity will be denoted into E. So E is equal to E is equal to E is equal to E is equal to force per unit charge. Force per unit charge. For example, we are considering into the two point charges Q1 and Qt. The distance between these two charges is R. Now we are finding into the force on Ft. Force on Ft means, so already we know the force is equal to, as per the Coulomb's law, Q1 Q2 divided by 4 by epsilon into R squared into AR divided AR. Now from this we are finding into the electric field intensity. E is equal to force per unit charge. The force will be Q1 Q2 divided by 4 by epsilon into R square along the unit vector AR divided by Qt. Now these two will be cancelled. So remaining is Q1 divided by 4 by epsilon into R square along the unit vector AR. So this is the electric field intensity. Now we are considering only for the point charge. Apart from the point charge, we have so many charges, that is line charge. First one is line charge. The charge distributed over the line or wire. Charge distributed over the wire. Okay. Normally the line charge will be denoted into lambda L. The L will be indicated the line, lambda will be indicated the charge. Second one is surface charge. The charge distributed over the surface. Charge distributed over the surface. The surface charge will be denoted into sigma S. Sigma S. Third one is volume charge. Third one is volume charge. Charge distributed over the volume. Over the volume. The volume charge will be denoted into rho V. So now we are discussing into the four type of charges. One for point charge. The point charge will be denoted into Q, and the line charge will be denoted into lambda, and the surface charge will be denoted into sigma. The S will be indicated the surface, L will be indicated the line. Similarly, the volume charge denoted into rho V. So V will be indicated the volume, rho will be indicated the charge. So first we are going to discuss about the electric field intensity over a line. So E due to line finite. So let us consider the conductor. Now I am considering into the coordinates x, y, z, y, x and Z. I am placing into the conductor finite length. This will be A and finite length. The charge distributed over this line is plus. So after that I am finding into the electric field intensity at the point of P, so P of x comma y comma z. So I am taking into small differential length, that is dl. So this is the distance between the differential length and point P is r, and starting of the conductor and ending of the conductor. This will be alpha 1, this will be alpha 2, and the perpendicular line of this taking into 4. Now we are going to find the electric field intensity for this finite conductor. So we know the dE is equal to dQ divided by 4 by epsilon into r square along the unit vector AR. Now we are placing into the conductor in Z axis. So this will be 0, 0, Z dash. So this is for 0, 0, Z. So here we are taking into the line charge. So dE is equal to dQ will be replaced into dl divided by 4 by epsilon into r square. So the line charge will be denoted into rho L into dl along the unit vector AR. So we need the E only, electric field intensity only. So I am taking into integration on both sides. So E is equal to line integral of rho L dl divided by 4 by epsilon into r square along the unit vector AR. Here the length dl is equal to dz dash. So I am taking into dz dash means the conductor will be placed into the z direction. So that's why dl will be taken into dz. So after that we are finding into the unit vector. So we know the unit vector is equal to that vector divided by modulus of vector. First I am finding into the r vector is equal to x comma y comma z. We are finding into the distance vector at the point of P. So x comma y comma z along the differential length 0, 0, z dash. So r vector is equal to, now we can take the vector subtraction means, so x into ax plus y into ay plus z minus z dash into az. So r vector is equal to x plus y is nothing but a rho. So that is already we have studied into the coordinate system conversion from Cartesian to cylindrical. So rho is equal to root of x square plus y square. From that I am taking into x plus y, that is nothing but of rho a rho plus z minus z dash into a z, that is nothing but of I am taking into x y z coordinate, that will be converted into cylindrical coordinates a rho a z and a phi. Now we can substitute the r vector into here. You can take this is for equation number 1. Here we can substitute, means E is equal to integral of rho L into dz dash. dl is nothing but of dz dash divided by 4 by epsilon into r square into ar vector, that is nothing but of r rho into a rho plus z minus z dash into az divided by r, as per the unit vector differential. A vector divided by modulus of a, that modulus of r, so r into r is r cube. So E is equal to rho L divided by 4 by epsilon, that will be constant. You can take down the outside, means line integral of dz dash divided by r cube into rho into a rho plus z minus z a into a z. Now we are finding into dz value and r and rho value. So I am considering into this triangle. Z as rho or this will be alpha. So from this sin alpha is equal to opposite divided by hypotenuse z minus z dash divided by r cos alpha is equal to adjacent divided by hypotenuse tan alpha is equal to sin alpha divided by cos alpha is equal to z minus z dash divided by rho divided by rho. Now from the tan alpha z minus tan alpha is equal to z minus z dash divided by rho. So z minus z dash is equal to rho into tan alpha. You can take the differentiation on both sides. So minus dz dash is equal to rho into secant square alpha into d alpha, secant square alpha into d alpha. So here we are substituting into here, means we are substituting into here, means you can take this is for equation number 2. From equation number 2 becomes E is equal to rho L divided by 4 by epsilon integral of minus rho secant square alpha d alpha divided by r cube into rho into 0 plus z minus z dash into a. So we side of this side. So equation number 3 becomes equation number 3. So E is equal to minus rho L divided by 4 by epsilon integral of, so rho value from this, rho is equal to R into cos alpha, R into cos alpha A rho plus Z minus Z dash is R into sin alpha, R into sin alpha divided by R square into minus 4 into secant square alpha into d alpha. So E is equal to minus 4L divided by 4 by epsilon integral of, we have a R will be cancelled, R cube, this will be cancelled R square. So cos alpha 0 plus sin alpha A z into rho secant squared alpha into d alpha divided by R squared. R squared. So R is equal to rho by cos alpha. So 1 by cos is equal to secant. So rho squared. R square value is R square is equal to rho by rho square by rho square into secant square alpha. So this will be cancelled. 1 by is there. So minus rho L divided by 4 by epsilon into rho integral of cos alpha A rho plus sin alpha A z into d alpha into d alpha minus rho L divided by 4 by epsilon into rho. So now we are substituting into that, we are taking into the limit is alpha 1 to alpha 2. So sin alpha taken into sin alpha A rho into alpha 1 to alpha 2 plus minus cos alpha A is so minus rho A divided by 4 by epsilon into rho. So sin alpha 2 minus sin alpha 1 minus cos alpha 2 plus cos alpha 1. So this is the E value. From this the rho will be increases, means automatically E will be reduced. If the point P will be goes for away, means the electric field intensity rho will be increased, means the electricity field will be reduced. Will be comes into near, means so nearby the conductor the electric field intensity will be high, it will be go away from, means the electric field intensity will be reduced. Suppose we are extending into this one is equal to infinite line conductor, means So we are derived into the finite conductor. Suppose we are extended into the infinite conductor means, so infinite conductor means, so we are going to extend this conductor into infinite means, so z dash is equal to minus infinity, z dash is equal to minus infinity, and alpha is equal to alpha 1. So we get the alpha 1 is equal to pi by 2. Similarly, alpha 2 is equal to pi by 2. We can substitute into here means E is equal to minus rho L divided by 4 by epsilon into rho minus 1. The cos term will be 0. So minus into minus plus, so 2 rho L divided by 4 by epsilon into rho, this will be cancelled, so rho L divided by 2 by epsilon into, so this is for infinite line conductor. Similarly, we will modify into semi infinite conductor. We will modify it according to this. We can find the different condition of okay. So in this class we are going to solve some problems based on the Coulomb's law. So here they are giving into the 2 point charges. Q2 is equal to 10 microcoulomb at 2,0,0 point, and Q1 is equal to 20 microcoulomb at 1,0,0. Now we are going to find the force at the point charge of Q2. So last class itself we have said how to find the force. Now we are finding into the force at Q2 means, so force F2 due to Q1. So we can find the F21 is equal to F21 is equal to, so we know the formula is Q1 Q2 divided by 4 by epsilon into r square along the unit vector AR. Now the Q1 Q2 already given in problem, but they are not given into the distance between these 2 point charges. We are going to find the first distance. First we are find the unit vector of AR is equal to r vector divided by modulus of r. So r vector is equal to we are finding the distance vectors r2 minus r1. So r2 is 2, 0, 0 minus 1, 0, 0. So 2 minus 1, 1. So ax plus 0 plus 0. So we get the ax vector. Now we are taking into the modulus of r means, so root of 1 is equal to 1. Now we get the r value along the unit vector value. So we are substituting into here means F21 is equal to the Q1 value is 20 into 10 to the power minus 6 microcoulomb means, and Q2 is equal to 10 into 10 to the power minus 6 divided by 4 by into epsilon value is nothing but of epsilon r and epsilon naught. So 8.854 into 10 to the power minus 12. The r value will be 1. The AR value is the AX. Now we can simplify this means we get the force F21 is equal to 1.79 AX. The unit of the force is equal to Newton. Equal to Newton. This is the first problem. So very simple problem. Similarly, we are going to solve the second problem. Here we are going to find the again force but F1. So we are considering into the in first problem. You have any doubts whether you have copied? We go for the second problem. Yes. So we are finding into the F1 due to second charge. So we know the formula Q1 Q2 divided by 4 by epsilon into r square along the unit vector ER. So first we are finding into the r vector value. You can look into this problem. First we are finding into the F2. So that's why first we are putting into the Q2 value 2, 0, 0. Here F1. So 0, 1, 2 minus of 2, 0, 0. Now we are subtracting into here means minus 2ax plus ay plus 2az. This is for r vector. We are taking into the modulus means, so root of 2 square 4 plus 1 plus 4. So 8 plus 1 9. So that is 3. R value will be given. Now we can substitute the values, R values into this formula means we have 1, 2 is equal to Q1 value is 20 into 10 to the power minus 6 into 300 into 10 to the power minus 6 divided by 4 by epsilon value is 8.854 into 10 to the power minus 12. So the AR value is minus 2AX plus AY plus 2AZ divided by 3. So we can simplify this one and find the force. If you are simplifying this one means we get the F1 2 is equal to 1.99 into minus 2ax plus ay plus 2a. Unit of the force will be Newton. Do you have any doubt for these two problems? Similarly, you can try the remaining problem. You will refer in your textbook and find try the remaining problem. If you have any doubt, please ask in next class. Thank you.